All right, greatest common factor is something that I actually practice with my students way before getting real deep into quadratics. So if this is your first experience with that, it's okay because the examples in this practice are, we're gonna mainly keep them to linear and quadratic terms, which is the main purpose of this series, is to explore quadratics. All right, the main skill required to understand this idea is to be able to distribute, apply the distributive property with these type of examples. So go ahead and try them out if you would like to. Otherwise, let's check them together now. So remember, this implies, this first expression, that the -3 is multiplied. Distribute means multiplied by each term inside, all right? So the first term would be -3 times k, represented as -3k, and -3 times +8. Be careful, the symbol is -24. And that is the distributive form of this factored form. All right, next one is, now we're distributing not only a 4, but also an x. The 4x is distributed to each one of these. And we'll do them by parts. What is 4x times x? That can be represented as 4x squared. And 4x times -9 is a negative. Positive times a negative is a negative 36. Be careful, it's not just 36, it's 36x, okay? So there is the multiply form. There are 3 terms inside the something, the parentheses, and a 5 is distributed to each one of those 3. So let's do it one at a time. 5 times p squared is represented as 5p squared. What is 5 times -8p? It is -40, because remember, positive times negative is a negative, and it's 40p. And last is +4 times 5. It's +20. There it is. And be careful with the next example, because there's a negative. Not only are we distributing the 2x, but also the negative. So -2x is distributed to 7, meaning what's 7 times -2x? It is a -14x. And then negative times negative is what I want to point out for this next part. So it should be a positive term. I'm just going to write it to indicate that we already know it's a positive term. So -2x times -3x is +6x squared. There, that one is. So be careful with the signs. Incorrect sign makes the whole expression incorrect, not the correct multiply form. Distributing a -x to both of these terms, we'll go a little bit quicker, can be represented as -12x plus x. Notice that we have -x times -x. Oh, squared. I missed some things here. Let's reset that. I was trying to go faster and made a mistake. So -12x plus x squared. It's all right. Sometimes that happens when doing math practice. We're not all perfect. We make mistakes. Let's distribute this 8 to all 3 of these terms. We'll check them now. 8m squared plus 8 times 3 is 24. So 24m, and -16. There are the 3 terms when 8 is distributed. And lastly, we have to distribute a -2. So -2 times 3w squared is -6w squared. Negative times negative is positive 8w. Negative times negative again for the last term is +10. So check those, make sure that we got the correct, not only integers, but symbols associated with each one of those integers. All right, so there's distributive property, and something that hopefully you have some experience with, because to be able to understand the greatest common factor is to undo this process. We're just going to reverse it. So the word factor is already there, so it's some form of factoring. So we're not only are we going to do that, we're going to connect it to the previous factoring form that we had used. All right, so you can see how those two connect. So it's pretty nicely done in number 2. We'll start from the most basic examples. 5y minus 35. The question we want to ask or think about is, what is the greatest common factor? What is the greatest common thing out of these 2 terms? What do they have in common? Notice how they don't both have variables. So the only thing that they seem to have in common is a 5. Both terms seem to have a 5. And remember, it must have been 5 times something. If you remember how we started the previous examples, all we're doing is reversing the process. We're starting with something like this, and we want to end up with something like 5 times something, or -2x times something. Look at these, all right? So there we go. We set it up that way, and now we think 5 times something. How did we get the 5y? What's the only factor missing? It's the y. You can check that 5 times y will give you this 5y. And then another way you can think about it is 5y divided by 5. Notice that we are reversing multiplication. So you can think, what is 5y divided by 5? It's just y. And let's try that with the next one. What is negative 35 divided by 5? It is a negative 7. So that's one way that you can think about that. All right. And let's repeat the process and go a little quicker. X squared plus 8x. What is the greatest common factor? What is the term that they have in common? Notice how before it was a number, a constant like 5. Here, they don't seem to have any integers in common, but notice that there's an x squared term here, and there's a x term here, and there's also at least an x term here. So we can say, let's factor out the x term. And now we set it up as x times something. If we want to apply the same kind of thinking as before, let's think we're reversing multiplication. Let's use division. What is x squared divided by x? It is just x. And you can check x times x will give you this x squared back in return. Let's apply the same thinking here. 8x divided by x, it is just 8, but we're going to write positive 8 since it is an expression here. All right, and you can check by distributing the x to both of these terms and check that you get the initial result if you're curious, but that is the correct answer, or factored form, I'm sorry. Next one, be careful. Not only look for integers, but also is there a variable associated for the greatest common factor? What is the thing that both of these have in common? It looks like definitely a 3, but is there anything else? Yes, an n term. So 3n is the greatest common factor. So 3n times something. If you want to think about the previous problem, x is the greatest common factor. And the last one, the first one was 5 is the greatest common factor. So in this case, 3n is the greatest common factor. Let's use division. I like that method. What's 3n squared divided by 3n? That is just n. And negative 18n divided by 3n, that's just negative 6. All right, if you have another way of thinking about it, that's fine. I interchange my thinking methods too from time to time. And let's keep moving. Oh, one of the things that I wanted to point out is that if you only had factored the 3, then these two terms inside would have a common term of n, and then you would know, oh, this is not fully factored. All right, and for the next one, notice how for sure we notice there's a p as a common factor, but anytime you see like negative p squared or negative k squared, I'm going to encourage you to factor out that negative. It just makes life easier for us in the future. So we're going to say that negative p is the greatest common factor. And again, you can think negative p squared divided by negative p, that is the same as p. And 12p divided by negative p, that's just negative 12. If you're not sure if you have your factored form is correct, again, distribute the GCF to what you think is the factored form. And then if you do get this in return, then you did it correctly. Otherwise, adjust your symbols or whatever you missed. Excellent. So let's practice that idea 2 more times, it looks like. We're going to see now with 3 terms, however, this was just 2 terms. All of these had 2 terms. These get a little more advanced in that each expression has 3 terms. If you're curious or you know the term trinomials, they're known as trinomial. But let's apply the idea. Okay, so notice how none of these 3 terms have something in common. They really don't have anything in common. There's no common integer or coefficient, and there's no common variable. The 13 doesn't have a variable. So the only thing we can factor here is a negative and times something. And one way that I like to think about it is this is just the symbol for opposite. What's the opposite of a negative k squared? It is a positive k squared. So I'm showing you another way that I like to think about it. And I like to use that thinking a lot. What's the opposite of a positive 3k? It is negative 3k. And lastly, what's the opposite of negative 13? That is positive 13. And again, if you're not sure, then go ahead and distribute and double check. All right. And here's what I wanted to point out back to the initial way that the instructions were written. Factor completely. These are all completely factored form. There's nothing else that we can do to factor these further. But the question is, for these next few, do we know how to factor what's inside? And let's see. We do have a method. Can we think of 2 numbers that multiplied with positive 13 and combine to a negative 3. I only think of 13 and 1, 13 times 1, but can 13 and 1 make a negative 3? No, right? Then I think this is already fully factored. This one's already fully factored form. All right, but let's always ask that question. Can we factor what's inside? All right, so let's think about the next one. Again, I like to think, because there's nothing in common, I'm going to use my symbol for opposite. Our symbol for opposite says, what's the opposite of negative k squared? It is positive k squared. What is the opposite of negative 3k? It is positive 3k. And what's the opposite of positive 10? It is negative 10. All right, and we were going to ask the same question. Can we factor what's inside? Is this fully factored, or can we proceed? So can we think of the product is negative 10, the sum is 3, two numbers that multiply to negative 10, 10 that can also combine to a positive 3. And I think that one does have that possibility. This could still be factored further. We know that for k squared, it was k times k. And the two numbers that would satisfy this sum and product are some form of 5 and 2. Hopefully you had enough time to think about that, and it's positive 5 and negative 2. Look at that. There it is. While they look very similar, the last two examples, notice how this one can be factored further, and the previous one was not of this type. So that's something we're always going to be looking for, all right? So let's see how that looks in the next few examples. 2m squared plus 8m minus 42. Definitely not a variable. This doesn't have an m. But all three of these have in common a factor of 2. Notice how 2, they're all even numbers. So 2 can be our greatest common factor. And 2m squared divided by 2 is just m squared. Positive 8m divided by 2, it is plus 4m. And negative 42 divided by 2 is minus 21. Double check that for yourself. And always remind you to double check in the inside. Can that expression inside be factored further? The product is negative 21 and the sum is 4. Two numbers that multiply to negative 21 and combine to a 4. What are they? It looks like some form of 7 and 3, where the 7 is the positive and negative 3. Negative belongs to the 3. There we go. That checks. And here's the fully factored form. Look at that. That's, again, something that's more, it's combining GCF with our previous type of factoring. All right. So that's pretty cool to tie those ideas together in this video like that. All right, let's keep going. 3 more examples, and just to give you a little more variety, but to give you a hint of where we're going also, imagine if this had said solve and it was equal to 0. Could we now solve these type of equations? Look at that. Yes, we can very easily by factoring. Same here. If this was equal to 0, boom, we'll be done. M equals negative 7 and M equals 3. That's why this is a powerful skill too, all right? So imagine if all of these had equal to 0, which we're going to do in future practice, but that's the main idea of why we want to get good at identifying these type of factoring techniques. All right. The next example is it's a great one, because I want you to really think not only what's a common factor. That's not the important question, because a common factor is 2. Wouldn't that be the case? 2 is it's a number that goes into all of these, but is that the greatest common factor? Not only 2, it is 4. Is there a greatest common factor? No, 4 is the greatest. So that's the idea. We don't want to factor out of 2, otherwise it would be incomplete. We want to factor out of 4. That is the greatest common factor, and that's the definition. That's why we say the greatest common factor, not just the common factor. So now we have x squared. I'm going to go a little bit faster here. Minus 4x, and then minus 5. All right. And again, we were going to look inside, and can we factor this inside? The product is negative 5. The sum is negative 4. I think that's factorable. Let's double check. If not, I'll just erase this. X times x. What are we thinking of? Some form of 5 and 1. When x is negative, when we have a negative 5 and a positive 1, that definitely checks. And again, if this was equal to 0, then we can solve this very easily. That's the inspiration behind these. All right, next 2. See if you can do them ahead of me, or double check now. All right, greatest common factor. Remember, we want the greatest number, and in this case, it looks like it's simply a 5. We got lucky with that one. Nothing too difficult to think about. So this is w squared plus 2w, in however way you want to think about it, and then minus 8. But again, we want to know if this is fully factored. Product is -8, sum is 2. Can we factor that? Let's find out. Otherwise, like I said, I'll just erase these things. All right, so it looks like some form of 4 and 2, where it's +4 and -2, and that definitely checks. And last one, and again, notice this negative. Not only will we factor, it looks like the integer that they have in common is a 3, but don't just want to factor out a 3. To make this easier for ourselves, we're going to factor out a -3. And then we have x squared. Remember that positive divided by negative is negative 9x. And then negative divided by a negative is +8. And let's check to see if what's inside can be factored. I think that it can. So x times x for x squared, and the product is 8. The sum is -9. 8 and 1 should be satisfying that product and sum if they're both negative. And there it is. I think this is correct. Yeah, double check for yourself. And again, if this had been equal to 0, we would be only requiring one more step to solve this equation. So let's see how that works in the next few videos, and hopefully you can hear me in those. All right, have a good rest of your day.